Have you ever considered harnessing the power of oceanic depths to preserve our foods? Imagine subjecting food products to pressures up to 6,000 bar or 87,000 psi, which is equivalent to nearly 6 times the depth of the Mariana Trench. Welcome to The Drip, where we keep your mind hydrated with some science, music, and a mantra. I'm your host, Zachary Cartwright, lead food scientist at AQUALAB by Adium. In today's episode, we will be learning how high-pressure processing, or HPP, serves as a non-thermal technology to ensure food safety while preserving the nutritional and sensory qualities of food. This process inactivates foodborne pathogens and spoilage microorganisms, allowing the production of safe foods and even the development of new food categories. My guest today is Mario Gonzalez, high-pressure processing food application specialist at Hyperbaric in Spain. Hyperbaric is the world-leading manufacturer of high-pressure processing equipment for the food industry. During his time working on his PhD, his main research topic was to assess the potential of HPP in ensuring the safety of raw coconut water. This allowed him to delve into advantages and the limitations of this technology. Let's learn more from Mario together. Mario, thank you so much for being here today. What exactly is high-pressure processing?
Well, high-pressure processing, also known as HPP, is a non-thermal food preservation method that uses cold water to generate hydrostatic pressure. This pressure is applied to food products in their final package. So this means that flexible, elastic, and waterproof packaging materials are needed. The maximum pressure level used by the food industry is 6,000 bar or 87,000 psi if you prefer. This is equivalent to 6 times the pressure at the bottom of the Mariana Trench, which is the deepest point in the ocean. This high hydrostatic pressure leads to the inactivation of foodborne pathogens and spoilage microorganisms. So actually pasteurization does the same thing, but it requires a combination of time and high temperatures. But HPP achieves this goal, but with a combination of pressure and time. This means that the nutritional integrity and taste of the food are maintained because the process takes place at low temperatures.
And I see HPP mentioned more and more in the food industry. How long has it actually been used in the food industry, to your knowledge?
Yeah, HPP is quite a novel process, I would say. To go back in time, the first research paper dealing with the potential of HPP to preserve food was published in 1899. This is the late 19th century. And, thermal pasteurization was still something in its early stages. Researchers described how HPP extends the shelf life of raw milk. However, the industrial implementation of HPP took place in Japan in the late 80s. Fruit jams were actually the first HPP product introduced in the market. But it was not until the mid-90s, let's say, that it was implemented on a large scale. The avocado and the meat industries drove the exponential growth of HPP. So overall, we can say that HPP has been around for 30 years.
And you mentioned there are a few different types of products that are used, guacamole, maybe different meats. I'm familiar with HPP in pet food. What other products have you seen this move into?
Yeah, HPP is a very versatile technology. It is currently used as a lethal or post-lethal step for pathogen control in a wide range of products. Fruit juices, smoothies, cooked and cured meats, guacamole, as I said earlier, dips, salsas, ready meals, baby food, or even pet food. So you see many different type of food products can be processed with this technology. So these products have significantly extended shelf life due to the inactivation of spoilage microorganisms, as well as foodborne pathogens. So we achieve both things, shelf life and food safety.
And for all these different foods that you mentioned, what are some of the characteristics of those foods that will determine how well HPP is going to work in order to inactivate these microorganisms?
Yeah, to make it simple, we pay attention to 2 physicochemical characteristics of the food, which are pH and water activity. So these 2 parameters will determine the extent of microbial inactivation. For instance, high water activity is needed for an efficient pressure transmission, And when it comes to pH, there is a clear synergy between low pH values and HPP. So this means that a microbial log reduction would be greater in a fruit juice compared to a cooked meat, because the pH of the fruit juice is lower than that of the cooked meat product. But HPP is suitable for both products. I mean, pH only tells us the extent of this log reduction.
And when it comes to water activity, what value are you trying to stay above so that it's as effective as possible?
Yeah, so an optimum water activity value should be between 0.97 and 1. And I guess we are lucky because most food products fall within this range.
Why do you focus on using water activity and maybe not a moisture content value?
Yeah, because water activity gives us more information, I think. This parameter refers to the amount of water that is available for biochemical reactions. We actually need available water for this pressure transmission. So we have observed that food products with a water activity below 0.96 already offer microorganisms some protection against HPP. This is because water is required for this pressure transmission. And without water, the molecular interactions within the biopolymers, such as proteins or phospholipids, remain stable. So the biological structures of the microorganisms containing these biopolymers will remain stable and intact. So pressure makes nothing to these molecules.
And maybe you can touch on that a little bit more. What is HPP actually doing on a molecular level? Is it actually breaking molecular bonds, or what are we talking about here?
Kind of. Let's say that the HPP works under the Le Chatelier principle. This principle suggests that when pressure increases, the system reduces its volume to counteract this pressure-induced change to restore equilibrium. For instance, the working distance between molecular covalent bonds cannot be reduced anymore. So pressure does not break this type of strong interactions because volume cannot change. This is actually the reason for quality retention in food products, because nutrient compounds, flavor compounds are tiny molecules that within their structure they only have covalent bonds. On the other hand, pressure does break the weak molecular interactions, such as hydrophobic or electrostatic interactions. Proteins, phospholipids, are stabilized through this type of bonding. So as a result, microorganisms are inactivated by HPP because the primary target of HPP is the cell membrane of these microorganisms. And there are a lot of proteins and phospholipids there.
Does that mean that the biological value of proteins and amino acids that we still want to consume and get that nutritional value, we're not losing that value to those proteins? Is that correct?
Yeah, that's correct. The disruption of these weak molecular interactions is not related to the biological value. The biological value of proteins is given by amino acids. And the primary structure of proteins is not lost because the peptide bond between amino acids is actually a covalent interaction. And the HPP does not break covalent interactions. It is only the three-dimensional structure of proteins that is lost with the process.
And does that mean that enzymes, which are a type of protein, very important to food production, are enzymes also affected? And if so, is this concerning to that final product, or will the enzymes eventually regain their tertiary or quaternary structure and then be able to work?
So, yeah, enzymes are special proteins because they catalyze chemical reactions. As you said, the functionality of an enzyme is linked to its structure. So since HPP breaks the 3D structure of proteins, enzymatic activity will be affected. However, HPP does not completely inactivate enzymes. It is even possible, as you said, that after the process, these proteins rearrange and recover their original structure, so they keep working. For instance, this is why the pulp of fruit juice settles at the bottom of the bottle, because we are not inactivating pectin methylesterase, which is the enzyme that breaks pectins. This is also why new food categories have emerged. Think on avocado paste or guacamole. Those are good examples, because HPP drastically reduces the activity of polyphenol oxidase. which is the enzyme that causes the browning of these products.
And when it comes to the microorganisms, can HPP actually remove all the microorganisms? Is it making the final products completely sterile, or can some microorganisms still be there?
No, HPP is not a sterilization technique. For instance, molds and yeasts, they can be completely inactivated, but there are still some pressure-resistant bacterial species that will spoil the product in the end. For example, lactic acid bacteria are quite resistant to HPP, so some species will remain alive. Additionally, bacterial spores are not inactivated either. And this is a concern on low acid foods. By low acid, I mean foods with a pH below 4.6, because we have some pathogenic spore formers that can actually grow above this pH value. So for those food products, additional controls are needed. HPP is not a solution to control them.
Can HPP cause certain microorganisms to go into their spore form because it's adding pressure or it's changing that environment in a way that the microorganism goes into this survival mode and then forms a spore? Has any research been done on that?
That's a very nice question. I don't think there is research dealing with that, but I don't think that HPP will force this transition between vegetative and spore forming, because HPP is very fast. For a bacteria to transform into a spore, you need time. So I think HPP is most likely killing the vegetative bacteria and is not inducing the sporulation process.
Now you work on applying HPP to lots of different types of foods and applications. I understand your PhD work also included high pressure processing, and you looked at raw coconut water. What can you tell us about your research and your projects and what you found there?
Yeah, that's true. During my PhD, I worked with raw coconut water, which is actually low acid juice. It has a pH around 5.5. This product actually has a risk associated with the spore-forming bacterium, Clostridium botulinum. Since HPP does not inactivate the spores of this bacterium, I tried to understand whether the spores could grow and produce the botulinum neurotoxin in coconut water. So this was quite challenging because working with Clostridium botulinum requires a lot of care. It is quite dangerous, actually. However, the main findings of my work suggest that Clostridium botulinum struggles to grow in coconut water, but the reason remains unknown. I wish I had an answer, but I could not identify the reason that prevents spores from growing in coconut water. Most likely, I think that coconut water lacks some essential nutrients that the bacterium needs to grow, but I was not successful identifying those nutrients. And this is a pity because if we get to know the nutrients that are missing in water, the food industry could use that as a control. So as long as the concentration of this particular nutrient is below a certain level, coconut water would be safe, let's say, because Clostridium needs a higher concentration of this nutrient. But this is hard to identify.
And moving forward, what are some of the food groups that you think have the most potential to start using HPP that aren't really currently using this technology?
Dairy products, for sure. There are not many commercial examples out there, but this product category actually faces some challenges that HPP can overcome. For example, the shelf life of highly perishable products, such as fresh cheese, can be extended with HPP because the process is applied on the already packed product, so there is not cross-contamination after the process. Additionally, Listeria, Salmonella, E. coli can be controlled, hard and semi-hard cheeses. This would prevent recalls and even foodborne outbreaks.
Do you see any potential in other industries that could be using HPP? I know you and I both work in the food industry, but have you seen other industries like cosmetics or pharmaceuticals or other things where you think that this could benefit?
there is a huge potential in both industries, the cosmetic and the pharmaceutical industry. The cosmetic industry is very interesting because I think we are more concerned about things that are added to cosmetics. We want some of these additives to be removed from the cosmetics because those chemicals, we don't actually know what they do. And most of them are actually antimicrobials that we need to put in the cosmetic to prevent the growth of molds and even bacteria. And as I said, HPP is applied in the final package of the product. So one could remove those antimicrobial compounds and apply HPP instead. So this would be a nice way to preserve the cosmetic product and to remove these chemical compounds.
And my last question is just about the process. So companies that use high pressure processing, do they generally take their product and ship it somewhere or go to a nearby facility for processing? Or do you see more and more companies bringing this technology in-house? What does the actual process look like?
Yeah, both options are possible. So it really depends on the business model and the needs of the food companies. Some companies prefer to have everything under control. They opt to purchase a machine. But other companies, they purchase the machine, but they offer the service to other companies. So this is what we call toll processing. These toll processors, they don't produce any food, but they only offer the service to other companies. And this option is ideal for the small companies that cannot afford their own machine. So most toll processors also take care of the logistics to distribute the product. So you see that HPP is quite accessible in different ways.
Great. Thank you for that. And switching gears a little bit, Mario, what music recommendation did you bring with you today?
Well, this is maybe a hard question because it depends on my mood that I prefer some songs or others. But today I feel comfortable with the song from Coldplay called The Scientist. I was very young when I listened to this song for the first time. And I found the lyrics very emotional and deeply meaningful. I thought the song was written for me. And I guess this is a common emotion at that age. And the fun fact is that becoming a scientist was not even one of my plans. But now, as an adult, let's say, the song makes me think about the time that I have missed spending with the people I love. Due to the dedication to science or to volunteer associations. So yeah, it is hard to find the balance. And this song.
Yeah, it's always tough to balance. And that's why I also ask guests for a mantra or a saying or something that you use to maybe bring some more balance to your life. What mantra or quote or saying did you bring with you today?
I have this one in mind. Better to fight for something than live for nothing. We are here for a purpose, and I am convinced that science is the way to progress, to make this a better world. Instead of leading a routine life where the only motivation is to collect the monthly paycheck, I prefer to set goals and dedicate time and effort to achieve them. And I think that following the scientific method is a nice way to set goals while considering, say, social development. So this gives me the motivation. I think that a routine life is selfish because focusing only on personal interests hinders the progress of the society.
Well, Mario, I couldn't agree more, and I appreciate your song and your mantra and your time today. I learned a lot myself about HPP and what it can be used for and its potential. So we look forward to checking back in with you at some point and seeing what other new products and things that you found where this technology can be used and help all different types of industries. So thank you so much for being here today.
Thank you, Zach, for the invitation.
Today's episode is sponsored by AQUALAB. In this episode, we discussed high pressure processing and how maintaining a water activity above 0.97 is crucial for HPP to work effectively. Did you know that not all water activity meters can accurately read above 0.7 water activity? This is because different water activity meters use different types of sensors in order to take a reading. While some instruments use indirect methods, like resistive electrolytic sensors or capacitance sensors, other instruments use primary direct methods, including dew point sensors and tunable diode lasers. If you're thinking about measuring the water activity of your food products, especially in the high range required for high-pressure processing. Make sure that you're using the right type of sensor for your application. A link to a guide on water activity meters will be in the podcast description. Today's song recommendation was submitted by Rutabe Directianian, who's a quality control officer at Pally Biscuits located in the Netherlands. She'll be singing a poem originally written by Marjan Farsad that is translated in English to mean blackberry eyes. Let's give it a listen.
شد با تو مثل خودت بود، کاش چشام مثل چشای خوشگلت بود، دو تاب نبات مشکی آلویی یا تمشکی که صد تا برق میزنه مثل میوه بهشتی. کاش میشد دوباره برف و بارون بباره، الستون و ولستون تو رو پیش من بیاره. کاش باز نگاه میکردم تو چشمای سیاهت، برف میومد و میشست رو گونه گلابت. بالا رفتیم.
To round out this episode, I'll be offering another mantra. As a reminder, a mantra can be a syllable, a word, or a phrase that you repeat to yourself to feel calm, motivate yourself, or express something you believe in. This episode's mantra is, I breathe in confidence and I exhale fear. I'm going to repeat this 3 times, and maybe you can say this to yourself or maybe even out loud. All right, here we go. I breathe in confidence and I exhale fear. I breathe in confidence and I exhale fear. I breathe in confidence and I exhale fear. As you keep this mantra in mind, I also challenge you to think about what is working well in your life right now, and how would you live your life differently if you knew that no one would judge you. Thank you so much for listening to this episode. My name is Zachary Cartwright, and this has been another episode of The Drip, brought to you by AQUALAB. Stay hydrated and see you next time.
بالا رفتیم آب بود، پایین اومدیم دود.